One of the things of content that I keep thinking of that I need to produce and talk about is the new math. New math, the new math, the Common Core math. One of the common complaints of so many parents, when I ask parents, what the challenge is, one of the things that I hear a lot is parents who say, hey, I can't do my child's fourth grade math homework, okay? And I hear this from highly intelligent professionals. One friend of mine's a doctor, okay, couldn't do her daughter's fourth grade math homework. And so, and the common refrain is, well, I know how to do math. I can do fourth grade math. I can do fifth grade math. They think they can. They actually can't, because people think that fourth grade math is just, add, subtract, multiply, divide. Fifth grade math, what could it be? How hard could fifth grade math be? But the complaint is that I know how to do the math. I know how to do addition, subtraction, multiplication, division, but I can't do it the way they're doing it in school. So because of this new math or the Common Core math. And I've been in this situation also. When I have a student, in fact, just had it yesterday with an algebra student, ninth grade algebra student. You ask them, and often I can see the problem. I can see the problem they have, the assignment, so to speak, the actual math problem they're given. I know how to solve that problem, but I need to have to ask. I used to have to ask. Now I'm, pretty much know, because I work with so many schools and so many students in so many locations and countries that I can now know this. But I used to ask. I say, okay, I know how to solve this problem, but I need to know how your teacher is asking you to solve this problem. Because I don't want to contradict. I want to, first, the teacher wants you to do it the way they showed you, because they're grading you based on that. And number two, I don't want to confuse you. So therefore, I need to know how they're teaching you. And that's the problem the parents have. They're saying, I know how to do the addition, but when I look at the way my child was taught to do addition, they say, this is crazy. I can't do this. And they're puzzled. So what I'm here to tell you is I'm going to tell you. Okay, so going back to the pond example, right? So you have a pond, and you have a path around the pond, a walking path. And you can go around the pond. You want to get to the opposite side of the pond. There are really two ways you can go. You can go left, you can go right. And because the pond is only a foot deep anyway, you can walk through the pond, although that the signs will say you're not allowed to, and you'll get messy and muddy, and it won't be a pleasant experience, but that is possible. So in our attempt to explain to the kid that, okay, you want to show them how to do it. Okay, you go out of your house, you make a left. But if you only explain that, then they think that the only way to get on the pond is going left. They will not understand, but what you really want to do is explain to them the larger concept of it's a round pond, or you can go left, you can go right, you can go around this way, you can go around that way. You could go across it, but that'll be messy. But we don't want to burden them with all those complicated details, right? We're afraid that that's too much detail. It's too complicated. So we just show them one way. And then someone comes along and says, showing the left way they're not understanding. So we'll show them the right, the way to go right, the other way. And so they think that is the appropriate way. And the result is you've confused everyone. Maybe I'm confusing you right now. So in an attempt to not burden kids with too much detail, but you want to give them understanding without giving them too much detail, we are essentially giving them, the compliant kids, the obedient and compliant kids, a mechanism, just a different algorithm, a different mechanism that they will also follow blindly. You didn't accomplish the goal. You replaced one obedient mechanism or algorithm with another one that was intended to explain the underlying concept, but doesn't. All it's doing is replacing one misunderstood mechanical algorithm with another misunderstood mechanical algorithm, and at the same time created a gap or a tension between the parent and the child. Because now even the parent who knows how to go around this pond, who knows how to do math, can't help their kid in school because they're shown to go right instead of go left. And there's another famous video I love this video. I think it was JP years ago, a video of talking about how stupid school is. And he's right. I used that video years ago and watched it over and over again. It was a wake-up call to all teachers. It was basically saying, hey, I learned in school, he was British, so I learned in school the quadratic equation, negative b plus or minus square root of b squared minus 4ac over 2a. I think I got that right. And they taught me this quadratic equation, but they didn't teach me how to balance a checkbook. They didn't even tell me what that was. They drilled me in Britain, London, UK about the 8 wives of Henry VIII, and they learned the sequence of how the 8 wives died, beheaded, whatever. He says they taught me all this nonsense, but they didn't teach me how to drive a car or do something useful. And so, in that video, one of the things he says is like, they didn't teach me how to balance a checkbook using a calculator. So they were so busy teaching me the quadratic equation and stuff that I don't need, that they didn't teach me what I do need. And here's the one fallacy, the mistake he's making. And that is, so now we think, okay, why do I have to learn addition and subtraction, multiplication, division? I got a calculator. Okay, I can use a calculator. So why do I have to learn addition, subtraction? And so, for example, I want to know what 5 plus 4 is, or 19 plus 20 is 3. Why do I got to learn that algorithm? Whether the new math, the old algorithm, the new math, or the new math, or the Common Core, I just have to know how to use a calculator. And the answer is, drum roll, if you go straight to the calculator, or let them use a calculator, as we do. One of the problems is the kids who never learned arithmetic are now in algebra, and the algebra teacher, for good reason, is letting them use a calculator. But the thing is, they're letting them use a calculator because they're giving them problems that cannot be solved easily by hand. Okay, like what is the sine of 25, for example, or what is the square root of 5? Okay, those are irrational numbers and cannot be computed easily, and not without a calculator. But because we let them use a calculator, they have stopped the thing. So give it just an example. Real student, smart student, 8th grade student, really smart, capable, who wants to be an engineer, by the way, encounters a problem in our work of -1 times 2/3. And he reaches for his calculator. And I'm thinking, stop, what are you doing? -1 times, you don't need it. You do not need a calculator. But why can't I use a calculator? The reason I want to use a calculator is because that calculator has prevented you from understanding that 1 times anything is simply itself, and a -1 is simply the negative. So -1 times 2/3. And therefore, it's not a problem that you're using the calculator. It's a problem that because of that calculator, you are not understanding the underlying concept. You don't understand what you're doing. Now, before the advent of AI, 5 years ago, I would have said, well, you say, oh, well, to multiply 8 times 5, I don't need a calculator. I don't need to do it by hand. I'll use a calculator. So then, even an algebra expression, there's an app, Photomath. It's still around. It's a great app that lets you take a picture of an algorithm, even a handwritten algebraic expression, and solve it. Not only does it solve it, it figures out what the problem is, it figures out what the question is, and answers it. So but if you gave it a word problem, okay, so give it a word problem, like you can't enter into Photomath, for example, so this is talking, before ChatGPT, if you get the following second grade word, this is a second grade word problem, by the way, which most adults can't do, and which really is algebra 2, solving 2 linear equations, simultaneous linear equations. But the question is, if Harry has marbles, he has 14 marbles, he has blue marbles and red marbles, and he has 4 more blue marbles than red marbles, and altogether he's got 14 marbles. How many blue marbles and red marbles does he have? That, until the advent of ChatGPT, that you couldn't, even with a calculator. Okay, there's a classic example of my own son years ago. I tell the story often. We went to a Jets game, and my son says to me, who was not in school at that time, he had, like all the greats, had decided that he doesn't need school and dropped out of school, and thank God. God's help, he has become obsessed with learning and graduated college since then, and is doing very well, Baruch Hashem, B'li and Hara. But after the Jets game, he says, Dad, I saw a sign that the seats we were sitting in, you can buy season tickets for each seat. One seat season ticket for that seat that we sat in is $500 for the season. I said, okay, that's an interesting problem. So question is, if there are eight home games in the season, and therefore for the $500, what you're buying that seat, but for 8 games. So how much we bought just one game. So given that a season ticket for that one seat is $500, and there are 8 games in a season, what are they charging effectively for one game? And I didn't want to bother him with doing it on paper, so I gave him my calculator. I said, with a calculator. This is a perfect example of how calculators don't help. Okay, so I gave him a calculator and said, so figure out, given that one season ticket for a seat is $500, and there are 8 home games, therefore 8 games included in that season ticket, how much does one game cost? And he spent the next 10, 15 minutes punching away at the calculator, punching numbers and punching. And finally, after, 5 or 10 minutes, I said, whoa, what are you doing? I gave you a calculator. I gave you a simple problem. You have $500 for one game, and there's 8 games. How much is one game? And I said, so tell me what you're doing on the calculator, because he's working hard. He's typing things. He's punching things on the calculator. He said, well, I tried 40 times 8. I figured, let me try 40. And he did 40 times 8. And that was 320, which was less than 500. So he said, obviously, it's more than $40 per game. So then he tried 50. And he did 50 times 8. And that gave him 400. Still not enough. So then he tried 70. Let me try 70 times 8. And 70 times 8 was 560. And that was too high. So now he knows that the answer is more than 40, but less than 70. So being a smart kid, he said, okay, let me try 60. And 60 times 8 was 480. Again, too little. So you see, I realized as he's telling me that, like, OMG. He doesn't understand he understands the concept. He understands multiplication. He doesn't understand that the dollar amount for one ticket times the number of games is going to be the total cost. And he's trying to figure out, given that he's given the total cost, trying to figure out the cost of one, he's doing it by trying to reverse engineer the multiplication, which is a highly intelligent thing to do. Commendable, except it's not efficient. And on the one hand, it's good that he's thinking, and on the other hand, I realize, he doesn't understand division. So that's what division is. But because of the trauma of all these algorithms and the trauma of going to school and the trauma of feeling stupid and not wanting to do math, that prevents them, it prevented him in that case, from understanding division. Because long before he got to division, or while division was being explained, it was so complicated. And if I've confused you on this message, think about what the kid is getting. Okay? I believe, if you watch this video that I'll put together, you will be confused. I talked about this guy, JP. I talked about the eight wives of Henry VIII. I talked about the pond. I talked about, and all trying to explain simple addition. And if you're confused, that's what your kids are getting. And by the way, the smartest kids are looking at that and getting the most confused. Okay, so if you found this confusing, I expect you would, because what's this guy talking about? Okay, that's what's happening to your kids. That's what your kids are being confronted with. And the smarter the kid, the more confused they get, the more pain they're in, the more frustration they have, and the more they will hate math and think that they are not good math people and can never learn math. Whereas the quote-unquote lesser intelligent kids, they, either because they were forced to by their well-meaning tiger parents, you got to learn this, you got to do your homework, they just gave up trying to understand it and just did it. Okay, they just did what they're told, but they didn't understand it, and they still learn to resent math. And so you have two paths of so many, and then you have the few individuals like Alex Ramosi and my friend, the lawyer, who basically later in life decide that no, just because it wasn't explained properly, turns out I need math, I need to figure this out, and they learn it on their own and go on to become very successful. But so many more did not have that insight and fortitude and resoluteness, and they just say they go through life thinking they can't do math. And that's where you get the 71-year-old who called me and said my entire life was affected and downgraded by the fact that I always believed I couldn't do math. She speaks 5 languages. She's obviously highly intelligent, and she's got married, had kids, but her whole life she was traumatized and believed she couldn't do math. And now at the age of 71, now she's saying, I can do this. Okay, so really the advantage, this tremendous advantage I tell teenagers who think they hate math and think they can't do math, that your parent or grandparent who hired me to teach them math is doing you a tremendous favor. You have an opportunity when you're 15 and not 70 or 80 to change and fix the trajectory of your entire life by realizing that in fact you can do math. You are especially geared, your brain is particularly geared towards doing math. And the reason you thought you couldn't is because of all the confusion. And all the confusion was created in an attempt. The real irony is the confusion of the old math and the new math and the new math and the Common Core math, all these other methods that are confuse you and your parents and other teachers. It was all in an attempt to make it clearer. And so again, if you find this video confusing, that's what's going on. Yes, because I spent all this time trying to clarify, but unless you take the time to go through it in detail and figure out what I'm saying, you will probably roll your eyes and say, oh my God, he made it more confusing. But that's what's going on. The video I was talking about, I just found it with the help of ChatGPT. The name of the video is Don't Stay in School by Boy in the Band. And it's I think it's 7 minutes. I just listened to it again, and there's so much truth. He's right. He's complaining about how he was taught all this useless knowledge and not do anything useful, how to get a job, how to find the causes of disease, how to save millions of people by finding cures. And instead they taught me the quadratic equation. Instead of telling me how to cure disease, they told me how many people died if the number of people died is a prime number. So it's a great video. And it's a great example. And he's right and he's wrong. Okay? Why? One of the things he said in his video is because in school, and he's right about this, in school, one of the things they teach in school is mental math. Okay? And he says in his video, the satire video, well, they taught me mental math, but didn't tell me how to use a calculator. And, they didn't figure that I'd have a calculator in my pocket. So why learn mental math? Why burden a kid with learning mental math? When in fact, everybody's got a calculator on them 24/7. So what he's not understanding, and by the way, he's right about, I'm convinced that one of the reasons for dysfunction in math, one of the reasons is the pushing of mental math. Now, what's wrong? Now, the other side is what's wrong with mental math? The reason they're teaching you in school mental math is they want to teach you to reason. Well, it turns out that from lots of experience with lots of kids, okay, one of the reasons for the dysfunction in math is because they were pressured and traumatized, literally traumatized, and told that they had to be able to do mental math. Those that couldn't or had trouble with it got traumatized, believed they're stupid. And again, the purpose of the mental math is not because you're not going to have a calculator in your pocket all the time, is to learn to reason. But ironically, those that learn the mental math and learn to reason, those are the very same ones that can't do algebra or can't do math also, because the mental math was to help you reason, and reasoning is important. It's very important to be able to reason and say, well, if x plus 2 equals 10, what is x? If I have an unknown number of dollars in my pocket and $2 more will give me enough to buy a ball, which costs $10, we want the kid to be able to reason, a 6-7-year-old to be able to reason and say, well, if $2 more will give me 10, how much money do I have now? That's 8. And we say, that's great. But the problem is now that you get to 7th grade, 8th grade, 9th grade, and then we say, no. The way we do it is we say X. We have a thing called X, which is the unknown variable. And we call this algebra now. And the equation, you have to write an equation that says X plus 2 equals 10. And the way to solve that equation is you subtract 2 from the left side. Then you got to do the same thing on the right side. Let me show you all these balancing reasons why balancing. It's got to balance. You got to have, if you subtract 2 from one side, you got to subtract from the other side. All this complexity, and then when you subtract 2 from X plus 2, and you got to know how to combine like terms, and X plus 2 minus 2 is really X, and then 10 minus 2 combined like terms is 8, and voila, and the kid rolls his eyes and said, you trained me to reason through that problem 10 years ago as a kid, and I learned how to do it. I can reason through it. I don't need your stupid algorithm. I don't need to subtract 2 from both sides. I don't need to combine like terms. I don't need to do all this stuff. Obviously, X plus 2 equals 10. X is going to be 8. Leave me alone. Find X. X is right here. Leave me alone. No. But then you show them a problem of X over 2 plus 5 over 3 equals 3 over 7. And then they freak out. They can't do it. Because that problem they can't figure out in their head so easily. And because the algorithm seems stupid, the purpose of the algorithm was to show them how what was behind the reasoning. Okay? It goes both ways. The reasoning is behind the algorithm, and the algorithm is behind the reasoning. You have to understand both. You have to know how to go left around the pond and right around the pond and understand that both are necessary. And sometimes you got to know how to cross the pond in a boat or walk across the pond and get muddy, depending on the situation. But in our attempt to protect kids from that detail, we just said, learn this algorithm. So in the 3rd grade, we said, learn the algorithm this way, reason through it, do mental math. And then in 7th grade, we said, no, you got to do it this way. And they reject both. And those are the smartest kids, and those are the ones that hate math. I guarantee it. I'll show it to you over and over again.